This is where it all comes together. In this video, we'll take the printed parts, the seals, the Raspberry Pi, and the camera, and assemble a fully weatherproof AllSky camera. Then seal it up for the night sky. This is the payoff of the whole series. If you've got your parts printed and your Pi running, grab your hardware and let's build it. I really wish 3D printers were this quick. Both of these components took about a day apiece. Now we're ready to attach the dome to the dome cap. And this dome I'll have in the parts list. It is actually sized specifically for this cap. So whenever you're using the configurator, whenever you size this, the default settings basically allow this dome cap to sit right inside this circle. Now you can resize the dome cap if you have a different size dome, and say your dome is a little bit narrower. Say this, it's not this full radius that we have on this one. So if you need to resize it, you can actually bring these sides in the configurator tool. So this way you'll be able to accommodate maybe a smaller dome. It's going to be difficult to accommodate a larger dome simply for the size of this dome cap is a fixed width. It's not going to really work well to try to increase the size and still be able to mount it onto the body of the whichever tube you're using. So the part number will be listed in the description. I'll have all the items that we're using on this build in the description with links to Amazon where you can pick them up. Also important is the sealant that you want to use. I'm going to use Lexel on this one because I've used it quite a bit in the past for other projects, and it does a very good job sealing plastics to other objects, whether it's plastic to plastic, plastic to metal. It does an incredible job of sealing things. I would avoid using standard silicone window caulks, things like that, simply for the fact that they can flex or crack at the most inopportune time, especially if it's raining. You don't want to have a leak in your seal. So Lexel has been a very good product for me to use. So what we're going to do first, this Lexel is very sticky and messy, so definitely put your cap onto some type of a table cover. You don't want to get this on your kitchen table or your workbench. And what we're going to do is we're just going to apply a thin bead around the edge of this. So we're just going to apply just a thin bead around this, and then we'll take our dome cap and seat it on there. And once it's seated, try not to move it. Let it start curing. Just kind of set it off to the side and just let it cure for several hours. I would even recommend putting it on the body of the enclosure yet. Just give it a day before you do any kind of touching on it. So we'll go ahead and start the sealing applying. And make sure you cover all the way around. Don't let any gaps appear, because that could result in a leak in your dome, which is the last thing you want with your electronics inside. And I'm not applying this as cleanly as I could, but it's going to be up in the air and nobody's going to see how ugly it looks. The main job is the functionality of the seal. So we can see all the way around. We got the sealing applied. Look for any gaps that you may have in there. You don't want to have any gaps at all. And the sealing this side here could actually use a little bit more. Apply that on that corner. And on the dome cap, it comes completely wrapped in plastic on both sides, this side here and all the way around the top. It also has a kind of a plastic wrap that only covers the top. I pull all the plastic off with the exception of the dome cap plastic. I leave that on just so that I don't accidentally scratch it while I've got it on my workbench or any areas that I'm maybe working in. So once you're ready to apply it, push it on there and push it down with good force. You'll probably have some squeeze up on the edges, which is fine because our lens is not going to be looking at that side of it. It's going to be above the rim of the cap. So push it on, make sure it's good and secured in there. And it feels like you can feel it moving inside the ring itself, which is fine. The outer ring where the lip of the dome is. Actually just about 1 millimeter on each side gap. So that should be good. You could wipe this with your finger, just wipe the edges to catch all that. If you just wanted to make it look nice, make sure you have a wet rag nearby that you can wipe your finger off with, because this stuff does get nasty. And as an example of why you want to keep that plastic on there, if your fingers have any of this Lexel on them, you don't want to touch the lens, because if it dries up here on the dome cap, you will definitely see it in your camera, and it is very, very difficult to get off cleanly without scratching the dome. So Yet another reason to keep this dome plastic on top while you're applying it. So that looks pretty good. I'm gonna just push this off to the side, let it cure. I'm probably just gonna let it cure for a full day just to make sure that there's no issues with me bumping it and trying to put it onto the housing early. We still have a lot of work ahead of us, so it'll be fine to cure off to the side. Okay, we're to the part where we're actually going to build our AllSky. These are all the components that you would need. Not everything is required. Some things are optional, and I will point out which things are completely optional. It just makes life more convenient after you get one of these set up. And if it's far from you or if it's high in the air, you don't want to have to climb on a ladder to reset things. Some of these components will make life easier. So let's get started. The very first component we have here, this is just plastic glue. This will be used to glue the screen to the enclosure. So like on the bottom of this enclosure, this is our fan hole, so the fan sits on the inside. We need to have a screen on here so that we don't pull bugs and other things into it. To make the screen cutting easier, I have these templates here. This basically is the width that you would need for the actual tube enclosure part. You would actually just cut 2 of these. So you'd print this out. You only need 1 to actually print out, but basically put it on the screen, cut it, and then put it again at the end of that, cut it one more time, and that's the exact length for the circumference of the inside of the tube. This bottom part, this is basically put this down on your screen, cut around it, and that screen will fit perfectly inside of here. You can just put little dabs of glue kind of on some of the support parts. And when you press the screen to that, it'll seal tightly. And there's also a stencil for if you're printing the standard tube, the vents on it has the same vent ports on the neck of it that the tall enclosure have, but on the bottom, the ports are actually around the edges like this. And on that system, it's really designed for kind of a chimney effect where it's a passive heat transfer. So as it warms up inside, air will pull through it and move itself up to the top. Hopefully that makes sense. Let's see, other components, the wire that we'll use, since all the internal wiring, it's a very short run, so 16 gauge is more than adequate. You could actually go with an 18 gauge if you wanted a thinner wire to work with. This is our power cord that we're going to use. Now, at my observatory, it's an off-grid observatory, so everything runs off 12 volts. So all the components that you see here are also 12 volts. So a 12 volt system just natively supports this. If you're running off of your house power, you've probably got a 110 connection. You will need some type of a 110 to 12 volt converter so that you can power your equipment. Obviously, you don't want to throw a 110 plug into your power distribution block and try to power this other stuff. You'll see a lot of smoke and sparks and probably a fire. So with this is basically just the cable that will run up into the housing underneath. And this is just a quick connect. It's a weatherproof quick connect. So on this side, you have the positive, and that's the positive lead going up in there. On the other side, the positive lead coming from the battery would obviously be protected. So it'd have this rubber part on this side, and the ground would be exposed like that. So the two would be able to mate together here. Let's see what else we have. Our O-rings. So this is on the bottom O-ring for the tall enclosure. This would basically just kind of sit down here and rest on this little ridge. And all this does really is just ensures a good seal so that if you have bugs or something that go past the threads, they shouldn't be able to make it past this thread on here. Now, this top one, this black one that we have here, this one actually goes on the top of this enclosure. So when you put your dome on, you screw it down, it'll seat tightly to that. So now both these rings, the top O-ring, the cap seal that we'll call it, it is a 112 millimeter inner diameter. So it just sits on this ridge, and when you put the cap down, it seals tightly on that. The thickness of this cord is a 3.1 millimeter, but I will have parts linked to these that you can buy these directly on Amazon. But if you have a TPU filament on your 3D printer, you can certainly print these yourself, and these templates are included in the Skyforge Designer. So just pick those from the list, send it to your printer, and it will print. You can print these if you have the TPU filament for that. Otherwise, you can buy these directly off Amazon. I think you have to buy probably like a 5-pack of them or something like that. See, next we have, now this is completely optional. This is a thermostat that actually controls the fan, turns the fan on and off. Now, you can control fans with your Raspberry Pi based on temperature, but I do not run this camera during the daytime. This camera is only a nighttime camera, and since it's a astrocam, it doesn't really make pretty pictures during the day. It's really geared towards the night sky. So with this, during the daytime, even though everything is off, I still like to keep the enclosure cool. So if it gets above 100 degrees, this little thermostat kicks on and it turns our fan on. This little fan that we have here, it will turn it on. After it reaches, it will get up to whatever temperature. Say we have the threshold set at 100 degrees or 110, it'll turn on until it gets all the way back down to 95 degrees, and then it shuts off, and it just repeats that process all day long. Now there may be certain days where it's extremely hot outside, and once it turns on, it doesn't turn off until nighttime, but that's fine. We're keeping airflow running through there and keeping everything overall cooler in the box. I won't say cool, but cooler. Let's see, and that is an optional item. You do not need that. You could certainly, if you're running your Pi during the daytime, you could certainly have that turn on the fan for you, but I don't run my Pi during the day, so that's why I have that device in there to help control the fan. This is a buck converter, so this is basically what you're looking for on your Pi power supply. You want to make sure that it can put out at least 25 watts and it has a 5 amp output. This is crucial because if you buy a cheaper model that may only have a 2 or a 3 amp output, and it will probably only output 15 watts, your Pi, if you're using a Pi 5, it'll likely reboot throughout the day and night because it's not being supplied enough voltage. So you need to make sure that you get it's the USB power. It's taking 12 volt, converting it down to 5 volt, giving the Pi sufficient power to actually run. Next, we have screen. This is the screen material that we'll put at the bottom of the cradle and then at the neck of the tube. Wire strippers. It doesn't have to be this style. It could be any kind of decent wire strippers. And then I think we already covered the electrical wiring. This is an M12 bolt, and it's a 1.5 millimeter pitch. And the reason you want one of these is if you do 3D print this yourself, this hole right here, I've printed threads inside here, and it's 12 millimeter threads with a 1.5 millimeter pitch. Some printers aren't very accurate when they're doing this, or they can get some debris inside there. So when you try to put your wire gland in there that you're going to run your power through that, it may not thread very well because you're going to be trying to twist plastic into harder plastic. So if you have a steel bolt, you can just thread that in there. It just cleans up the threads. That's all we're doing with this bolt, is just making sure those threads are good all the way through. And this way, when you put your wire gland in for your power supply wire, it'll be nice and clean, and that will thread right in. So that's all this bolt is for. And it's a 12 millimeter with a 1.5 millimeter pitch. So and this is the wire gland I'm talking about. So we'll take this nut off the end of it, and you'll see it's threaded. Let's see those threads. And what that does, that basically just threads right into this hole. It's hard to do with the camera right in my face, but anyway, yeah, it'll thread right into the hole. Just make sure you don't cross the threads. And basically, your power wire will run through this little hole, and as you tighten it down, it just secures it tight so that dust and spiders and stuff can't get into your enclosure. And normally these, when you buy these, you probably get 20 of them for $5, but you'll have them for other projects in the future. This is going to be our power distribution block. So what this does is your positive and negative, you decide A or B. I always just do the positive on the A side and negative on the B side. So where your power is coming in through the bottom of your enclosure, the red will go on that side, the black will go on the B side. And then when you look on the sides, you have these little labels. You have A4, B4. So A4 will be a positive, B4 would be a negative. So each device that needs positive and negative coming out of it, you would just insert them to those little sockets, tighten down the screws on top to secure them in, and you're good to go. That's a required part. Now these are extremely handy. I use these all over my farm. These are Wi-Fi power modules. So what these do is they'll just draw power from your power distribution block. This is a single module one. You'll see this is a dual module. They have a 4 module, and I think maybe an 8 module. I can't remember if I've seen up to 8, but I know I have single, duals, and quads. So these are really nice because when you power them up, you can connect to them on your phone and program them, and you can set schedules for them. You can remotely, if your Pi is hung up and you want to reboot it, you don't have to walk all the way to it or climb on a ladder to get to it. Just hit the power button and it shuts it off. So anything that you have on here, like with this dual module, you would have inside the app, it would show this module and say switch A or switch 1, switch 2. So you could actually have your devices powered through these ports, and I'll show you how to wire them. It's pretty straightforward. But you could say turn switch 1 off, but leave switch 2 on. So you could have your camera on one. If you have like on my 533, it's powered separately from USB, so it actually has a power connection on it. So I could have, say, my Pi running on this one and my camera running on this one. If the Pi is messing up or if the camera's messing up, I could just turn whichever one I wanted off. Could turn the schedule on both to be off, and that's what I do now, is that I have my Pi set to turn off in the morning, say around 9 a.m. It has a cron job that shuts itself down, and then 9:15, it automatically kills the power to it through a scheduled process that's built into the device. So these once you connect them, you don't have to mess with them on your phone anymore. You set schedules and it runs automatically for you. And they do run on Wi-Fi, so you don't have to have any kind of special radio or anything to communicate with them. But yeah, they're very nice modules to have, even if you're not using them for a project like this. If you have something that you need to remotely control, power on, set schedules, you can do it with that. And those are both optional, but I'd highly recommend. They're not very expensive at all. This is a PWM controller. This is what we control our output of our dew heater with. So you can see it when you'll hear it maybe click. But when you turn it, say about halfway up, that's going to send half of your 12-volt power to your dew ring. Whether you did a DIY dew ring or you bought one from the dew control people, it's good to have one of these because you don't usually ever need your 100% power to your dew ring. Normally about 50% is sufficient. You're just trying to heat the dome up just above the temperature on the outside to keep dew from forming. So it's a very nice module to have, and especially with my 12-volt system at my observatory, we need to control as much power usage as possible. So if we don't have to have something at 100%, let's not have it at 100%. And obviously this is the brains behind the system, whether you're using it in a enclosure or if you have a mini PC. This is what I'm using. This is Raspberry Pi 5. This is the NVMe hat that's on it. Just gives it a little bit more robust storage, a little bit more storage than I'd feel comfortable with trying to run on an SD card, especially for if you're doing a lot of intensive writing with it. But very nice little setup here. And let's see, of course we would need various tools. We have Phillips head and a little flat head, different lengths depending on which components you're going to try to get to. Various screws. Most DIY people always have a drawer full of screws, so there's chances are you probably have the screws and things that you would need. I'm very clumsy, so I keep these screws in bags. I don't know how many times I've spilled this tray and they've gone everywhere. Let's see, what else is there? I think that is it. So we will go ahead and move to our assembly part of this now. We will kind of template out how we're going to mount these various components. One thing that you'll see on here is inside here, you can see there's some little holes down there at the bottom, little pilot holes. That's where the fan will sit at, and this is for a 60mm fan. So this fan will go right down here into the bottom, and the pilot holes will line up directly underneath that. And this is a low profile fan too. So in this build, my 533 is a very tall camera, so I can't have it much taller than this because the tube wouldn't slide up into the tube. You'll see that where the Raspberry Pi actually mounts at, back here in the back, we have these little holes here. Those are pilot holes for the Raspberry Pi to connect to. So if I had a much higher fan, this is a low profile here, some other fans that I have are like twice this thickness. If it got any higher, I wouldn't be able to put the USB cables into the bottom of the Pi. If you're just running an ASI 676 or one of the puck type cameras, you're not gonna have that problem at all. You've got plenty of room to work with, but this is the max height that I could have on this particular cradle with this particular camera. And of course, this is where your components could be mounted to. You have all this space. You could mount from the inside as long as you're not crossing over and punching the board into another device on this side. That's, of course, you have that side, and you have a small panel here that you can work off of too. Everything up here, this is where the actual camera sits at. So these little fingers that are right here, these little 3 sections, those are what actually hold the camera, and they hold that camera very snug. And it'll be the same way with your ASI, your Player One. Any of the round ones or the hexagon ones will fit snugly into their respective holders. So that is that. Next, we will start working on laying out how we are going to mount these individual devices in there. Okay, so the first thing that we're going to install into our cradle is going to be this fan. This is our cooling fan that we will have hooked up to that little thermostat that I was talking about earlier. Now, this fan, I do not know which way the air blows. So that's an important factor on determining which direction this sits inside the cradle. I'm sure somebody probably knows the standard, like if the label's on this side, fan air blows this way, or maybe it's the opposite. I just don't know. So we're going to test it before we actually install it. Now, where this fan actually goes is down here in the very bottom. You'll see these little standoffs down there. Those are little bosses, little screw bosses that this fan I've configured this cradle to sit on. Now, this is a 60mm fan, and they generally have the screw holes in the same. They've standardized on that, fortunately, for most of the vendors that I was looking at. But basically, it's just going to sit down there in the bottom, however it goes, this way or the other way. It just sits down there in the bottom, and it will draw. My plan is to pull air from the top down. So when the tube is on here, when this is sitting up in the tube has those holes around the neck. It's going to draw air through that, down across all the components to keep everything cool, and exhaust it out the bottom. The reason I want it to exhaust out the bottom is I don't want air or dust or anything like that to be taken from here and blown up into the dome area, because probably look like those confetti balls that the kids used to roll around where things are just popping up in the air. Don't want anything like that. So I'm just going to take the air from the sides and pull it down across the components, keep everything cool, and exhaust out the bottom. But first, let's figure out which way this fan actually blows so we don't install it into the cradle upside down and then have to disassemble it, because once it's in the bottom, it's going to be difficult to reach around everything. Okay, so what I have is, I think I talked about these a little bit ago. This is the standard quick connect that I've standardized on my farm out here. And then I have these little battery cable type things that will just connect directly to the leads. So we will connect these two together and make sure this is off. We don't want to have an arc or anything. The power button's off. So we will just connect these two together. So you see how the red on this one is insulated coming from the power side, and then negative, and this is the red on this side. So these will just connect together. Quick connect creates a weather tight seal, and then we will hook up our fan. So we have our black cables here, our black connector, black wire goes to that side, make sure it's snug in there. And then we'll go to our positive, make sure that one's snug. Okay, keep those from touching each other. We don't want any fireworks. So we'll hit our power button and look at our fan. I will say one of the good things about working with 12 volt is it's very difficult to hurt yourself. Don't get me wrong, it can be done. I'm sure there's a lot of stories of people that have done it, but if you're careful, it's not like you're dealing with 110 or 220 or anything like that. It's very low voltage and you're usually not going to get hurt. So we'll hit this. Okay, fan's on. Yeah, it's definitely, air is blowing this way. So this side of the fan pushes the air up. So we're actually going to mount this facing down. Now, that blows out a lot of air. That's really nice. I wasn't sure how good this little low profile fan was going to be, but yeah, it blows air very nicely through the bottom. So that will definitely help keep things cool. All right, so we're good to go on that. This just kind of sits right down here in the bottom. And there's these little screw bosses that it should line up. Yeah, it lines up perfectly on that. I don't know if you can. Yeah, those line up perfectly. So we'll go ahead and screw those in, get that bundled up. And I'm probably not going to show this process. You can kind of figure out how to get your screw or how to get your fan screwed in and all that. But some of the stuff I'm just not going to be able to do with the camera running because I need to be able to see over it. Okay, so the fan is secured in there. It's holes lined up perfectly. Now, the next thing we want to install, since we have that in there, we want to install our pie. The pie is going to be mounted facing downward like this. It's the holes that I have in here. And let's see if you can see these two holes, 4 holes actually. There's a pattern for all 4 screws of the holes on the Raspberry Pi. Now, on this one, I do have an NVMe hat on it. Some of the holes are being occupied by screws that hold the hat on with the standoffs. So what I'm going to do, I'm going to not use the standoff on this corner. This hole on this side is already free. So I'm just going to use 2 screws to hold the pie in place, and that's more than enough. This thing's not going to be bouncing around or anything like that to where it would ever come loose. And what I'm also going to have to do, because the hat is directly over this hole here that I need to screw into the support on the back of this cradle, I'm gonna just loosen it so it drops down just a little bit out of the way so I can get a screwdriver into there, and of course that one will be no problem. But that's gonna be our next process. So we will basically mount that into the very back here, and then we'll come back to that and you'll be completely mounted up. But again, some of these steps does not require me to do it while you're actually watching. You can obviously see how it's going to be supported. So, all right, we'll come back to that one in a second. Okay, so I've got Raspberry Pi installed. We tacked it on the pilot holes that we already had drilled on there. And those are M2.5 screws. They're about 10 millimeters long, and they're the M2.5 diameter on there. But one thing I will point out, this is an early prototype cradle, and whenever I was designing this little gap, I thought this was large enough for the power supply plug to actually go in. I didn't bother measuring it, which was a mistake on my part. So there's a little jacket around the USB-C connector there, and it's wider than what this gap was. So I had to actually cut out some material here just so I could get the power to plug in there. Now on the new STL files, this is already cut out. This is already pre-cut out, so you don't have to do the little engineering that I did here. Basically, it'll start down here at this lowest HDMI port, down this port 2. So here's port 2, here's HDMI port 1, and there's the actual USB connection. My lighting is terrible right now, but maybe there you go. You can see it there. Power, HDMI 1, HDMI 2. This whole section is cut out on the new STL, so you will not have to do what I did here. Okay, so next what we're going to focus on is getting our power block installed. So I've already pulled the power wire in. It's got a little 12 millimeter cable gland. Remember, it threads up into this port. It's already pre-threaded. That's where you'll use your 12 millimeter bolt to clean the threads and make sure everything's good. And we'll have these just extending up into here. And what we'll do is we'll connect those to the bottom here where it says port A and B. So on our system, A is going to be positive, B is going to be negative. So I'll move the red cable, the red wire to the A side, and the black wire will attach to the B side. Now, if you've never used one of these before, it's a pretty simple concept. Let me get this over into the light so we can actually see. Basically, when you thread these in and out, there is a little screw or a little cap that tightens in there. So as I thread these up, see how that tightens it up? See how that closes that gap on the B side? If your wire was in there, it'd be getting squeezed and held tightly in that little bitty hole. Do that again just to make sure that the camera can actually see it. We'll tighten that up. That's tightening it clockwise, and then counterclockwise will open up the hole so you can put your wire into it and clamp it down. So that's pretty much how, and that's the same concept of these ports on the side. So you have your A4, B4, A5, same way it's all labeled on each side. And you'll basically just tighten these screws on top to actually clamp the wire down. So turn clockwise to actually tighten it and clamp the cables in, and then turn counterclockwise if you need to release the wires. So, all right, so this is going to go, basically it's going to install right here at the bottom, and so your power comes up through the bottom, goes immediately into this port, and then from there you fan out your power to any device that needs it. So we'll go ahead and get this installed, and we'll be back to that in just a second. Okay, so I got this power distribution block mounted. I was going to mount it down low, but when I actually put it down there and I did a dry fit of putting this cradle into the tube, there's a ridge on the bottom of this tube where the O-ring sits at, and that was just too close to where these things protrude out. So when it was down here, it was actually interfering with that O-ring ridge. So I've decided to move it up, and this way it's got plenty of clearance up here in this area where the tube is much wider, so you see it easily passes that. But once those two kind of start trying to connect together when you're threading it in, this O-ring ridge was actually hitting those tips. So decided just to move it up. It doesn't hurt the overall design of anything. It's just making things fit when you have very little space overall to work with. You want to optimize anywhere you can. So with that was basically just one revision in between the last video that we just started. So now we are going to start installing these power Wi-Fi modules. So I'm thinking this small one would go very well right here, there's actually two holes. You can see there's two holes right here. So that's the only contact or connections they have. So I'll probably put a double-sided tape pad on there just to kind of hold it in place, and then we'll get those screws threaded in there. Because the main parts you need to access are this back side. That's where one device would power into, and then of course this device, this is where it gets its main power from to control the relay, the Wi-Fi, and all the other components that are on the board. So our next process will be attaching that. Okay, we've got the Wi-Fi power contact secured onto the side of the supporting boards here. Now, one thing I do want to point out on here, as you install these components, kind of look down the ridge, tilt it down, and just make sure that you don't have anything sticking out that could actually obstruct the tube from coming down on this. And even better, just do a dry fit. So I'm going to take this, slide this up into our tube, just make sure this thing still threads in. Yep, we're still good there. Nothing's blocking it, and it slides right in, because nothing worse than getting everything assembled only to find out that you've got one or two parts that are sticking out into the channel that could actually block or obstruct the tube from being able to slide over it. And then one other thing I want to point out is I failed to do this cable gland. Once you get the power in there, you do want to make sure that you secure this cable gland. See these little fingers on here? As you put this nut on here and you twist that down, it's kind of tapered inside here, and it will start squeezing these fingers down really tight to where this wire, it would have a very, very difficult time pulling it out, because you don't want to actually snag this wire, have this get yanked out of your power block. And you don't want to have any kind of a situation where these things could get loose because this cable is continuously being yanked when it's not secured. So just push that up on there and tighten it up. And as you tighten, it will tighten those fingers down, and you'll see you have already a little slack left in here just in case, a little stress relief on the cables. But once you tighten this up, you'll be very hard pressed. You will definitely have to really be trying to get this to actually pull out and potentially separate from up in here. And I do have a little gap on that cable. I need to get that pushed up in there just a little bit tighter, but you definitely want to make sure this cable gland is tightened so there's absolutely no way this cable can accidentally get tugged and yanked out. So we'll go ahead, and next step, we're going to wire this in. We're basically just going to connect our positive and negative ports on here. And let's see, I'll probably look at the documentation. I don't see a positive or negative. Normally positive, it will be on the side, on the left-hand side. Let's see if we see that there. No, nothing's written on there. But I'll look at the documentation, but pretty sure this is going to be positive and that's going to be negative on these two right here, positive and negative. But I'll confirm that with the documentation. Okay, so the first wireless power module is connected. So this, I could definitely have made this wire shorter, but I started kind of getting into a constraint of being able to split these wires far enough to where they didn't become two independent wires, because just trying to split them, trying to get the wire cutters on there, wire strippers on there, it was getting a little bit further down. So that's fine. It's not protruding out into the actual area where the tube, where the slides up in the tube is going to get at. And if it does get in there, you can always just kind of use a zip tie to kind of just push it up like that to where it's not sticking out past that pillar. But this is fine. It's fine to sit just like that. We don't want to have it too much stress on that angle, because it could end up over time causing these wires to where they may want to pop out of their socket and shut off power to that. So, all right, so now I guess we can look at the other side. We have several options. We still have, let's see, we have our Raspberry Pi power module that we need to connect, and that is the USB cable. And of course these wires, they need to be able to somehow get over there to, they're actually not going to go to that side. The Raspberry Pi power module is actually going to connect to this module, which is going to be on the same side as it. That's what we're going to have, is the Raspberry Pi will connect to one power module and one power switch, and then the camera will actually connect to the second one. So what we'll do is we'll mount probably this something kind of at an angle, because it's a little bit wider than what the plate is, so we'll do that at an angle, and probably try to catch this one somewhere down here, like that. And we still have, let's see, we still have a PWM module that we need to find a home for. And then we also have this thermostat module that we need to find a home for. But I actually think I've got a pretty good idea where this can go. This can actually sit kind of like this. That was one of the things when I was designing this. I wanted to have a little tray where that could sit easily and not kind of have to figure out at the last minute where that could go. That drops right into that little tray there. Of course, if you don't choose not to use this module, and if you're using a dew sensor or something like that, you could, of course, strap that there instead. But you also, just keep in mind, you also have the whole inside of the board. Just be careful when you're putting your screws through there. You'll probably want to use some glue or standoffs or something like that, because screw right through that would get into your power module and, of course, into that little guy there. And of course, not everybody is going to be using a 533 camera, so this camera really constrains you as far as the amount of space that you have in here. You could go much taller with a standard cradle, or with the tall cradles. You have much more room. This is everywhere where the camera is sitting at. This could actually go way up and give you a lot more space for one module. So with the 533 build, you are constrained for space, unless you have a bigger printer. My printer only prints up to 254 millimeters, so if you've got a printer that prints very tall, you could, sky's the limit as far as your tube size, right? Okay, so we'll go ahead and work on getting this one mounted in here, and this is our Raspberry Pi power, and then we'll do our dual channel Wi-Fi power module. Will probably sit in this area, so I'll go ahead and get those two bolted in, and then we'll come back. Okay, so both these modules are mounted now. So this is our wireless power relays, so whenever we can set schedules and things, these things will automatically turn on certain devices. We can reboot the device if it's not responding, camera's having issues, just click a button, power off, power back on, beats walking out to wherever you've got your AllSky enclosure set up at, and climbing a ladder or whatever. I know in my situation it's about a quarter mile away, so definitely don't want to have to make that trip if I don't have to. Now, we'll probably be doing some zip ties and stuff to manage the wires. It's always a mess trying to make everything look pretty. You'll do your best whenever it comes to that time, trying to get the wires tied in, make them nice and tidy, because you definitely don't want them hanging out into this area where the enclosure will be coming over. So we'll make sure those are nice and tied up against that. So we'll go ahead and string our power cable wire across. We'll probably go up, over, and then back down to one of these. And I will mention, I forgot completely to mention this a while ago, whenever you're tapping your holes, use a drill. Don't try to force the screws. Don't just start trying to make your own holes with the self-tapping, because this filament it's plastic, and it can be like wood, and it can split. So if you're too close to the edge and you try to force a screw in there, there's a good chance you may crack that out. So go ahead and use a drill to drill your hole, and then use your M2 thread or whatever type of screw that you're using for your components. I'm primarily using the M2 class. I've got M2, M2.2, and M2.6 depending on the size of the holes. Some of these holes are only M2s, and then some of them are all the way up to M3s. I've just got a washer on these holding this in, but these are just M2 screws. And you see they do poke through just a little bit. Nothing's on the inside that would be affected by that right now, so that's good. And so far I'm happy with the way this is looking. Kind of had an idea in my mind how this was going to look, and it's coming around. It's working out well. Of course, everybody's going to have their own style of how they want to do things if you choose to use this enclosure, but again, this is not the best case scenario with this particular enclosure, simply for the fact that it's trying to support a very tall Astro camera. You would actually have way more room than what I'm showing here if you chose the default size. And of course, you can make these things smaller. I'm actually printing one now for my HQ Cam, a friend of mine's camera setup. So his is actually going to be much shorter. It's going to be a very compact design, but still using the kind of the wide body version where this slides up underneath there. He does want everything to be self-contained in his unit. He doesn't want to run a separate system outside of it, so everything will be self-contained in his also. So I think it's looking pretty nice. Okay, I've got the power Wi-Fi module wired in, and you can see it's kind of just wraps across, zip tied up, over, around, and then goes into these other ports over here. The power cable is the same thing, USB cable wrapping around, taps in there. I really wish they had a right angle adapter for this. I don't really like putting that big of a kink on a USB cable, but I guess we'll see how that pans out. I don't think it's going to cause a huge issue, but over time, who knows, it may degrade the quality of the wire inside just being pinched like that. But we'll see. And then let's see what else have we got. Of course, on the current STLs, if you decide to print one of these, you will have a much larger channel, so you probably wouldn't even have to go on the outside. You could come up through the middle and just come out and then back into that, because this channel here would be wide open for you to be able to work with the HDMI ports and the USB-C port on there. So yeah, we've got all that wired up. Everything looks okay there. And then I guess next we'll go ahead and wire in our thermostat, and then get our power and things connected on that. This is a unique setup on here, and I'll go through how the power cable and all that connects on here. But we'll go ahead and get that fitted in there and wired up. And then after that, we only have the PWM controller to hook up. And then of course I did another dry fit, as you would expect with wrapping these wires around the outside. This is actually going to tuck into the inside of that pillar. But with this USB cable wrapping around like this, putting it in there, you kind of just tilt it a little bit to get past this lip that's right here at the right inside of here. There's kind of it's that O-ring where it seats. Just kind of tilt it up on one side, and then it'll slip in there. And then of course just make sure it. All right, well, we'll go ahead and work on the thermostat now, and it's going to go right here in this little plate here. Okay, we've got the thermostat sensor connected now. Now, if you look in here, let me turn this upside down. The writing's actually upside down. If we're looking inside here, you see we have a K0, K1, positive 12 volt, and a ground. So those correspond to each one of these connections on here. So now the fan that's coming off of this is this really skinny red wire. This is going down to the fan. It's going to go into this first terminal, this K0. The ground, obviously, is going to go to the ground side here, but it's also going to share that with our power connector that we're going to run over to our power distribution block. But the unique thing on this situation is these two in the middle are both positive. So on that, we're going to use a fork terminal, and basically we'll just slide right up into that. Let's see if I can see it there. There we go. It'll kind of connect up in there, and we'll just tighten both those screws down so that they're both getting power to the device, but instead of running two separate wires, we're just going to run one with this one little fork terminal. We will tie that in. We will run this negative over to this side. We'll probably just twist in the ground on the fan with that, and then we'll run our fan positive over here. Once we actually get up and running, I'll show you how to program this device. There's also another little connector, and of course I forgot to connect it. It's this little white lead right inside there. I'll have to pull this out and reconnect that, but basically it's your thermostat sensor. It has to be able to have a sensor to tell it what the actual temperature is, but I'll pull that out and we'll get that reconnected. But in the meantime, we're going to go ahead and get these also connected to our power distribution block. So we'll come back to that. Okay, so the thermostat is wired in. Unfortunately, I did have to shift it over just a tad, because if you look down here where that thermostat cable needs to plug in at, I needed to be just a little bit more space right here. So it's still tacked in. It's got a screw holding it. It's not going anywhere. It's just not pretty, but at the end of the day, it's going to be hidden inside the tube, and I'll just tell everybody how pretty it is. But yeah, I think we're good to go now. So that is wired in. You can see that we've got that fork connector that I was talking about, that fork spade, how it runs up over here and plugs into the positive, and then the negative wires running up here into the negative, and of course the fan is just sharing that negative port, and then also the positive port that turns on once the thermostat temperature reaches 100 degrees. It'll kick power to that lead, which will then turn the fan on and then cool the whole system. Remember we faced the fan down, so air draws in through the neck of this tube, and then it flows down through some of these holes on the top here, and then kind of right down through the middle all the way down the bottom. And it really moved a lot of air. I was pretty impressed with the size of that little fan. You can see it from the bottom. We still got to put some screen on there. We don't want bugs and stuff climbing up in there. I actually had a situation on my old AllSky system where I forgot to seal the cable gland all the way. I forgot to tighten it up, and there was this little spider that got in there, and it was one of the nights of the Milky Way, and of course it got up into the dome and spun a nice little web. And I was just like, the next morning I was like, oh, he's just a spider doing spider things. It was all good. All right, so we will go ahead and move on to connecting our power relays now. And I'll go ahead and get these two connected, and then we'll go over which ports these plug into, because there's 3 ports on here, but only 2 of them are actually used. And we'll actually pull power over to that, and it'll make sense once you actually see it. Okay, so now we are ready to wire up the wireless power relays. So this is a dual channel, and you'll notice up here at the top you have 3 screws and 3 screws. So each set of 3 screws corresponds to the relay that it's sitting under. And the way these wire up is, if you're looking at it from this position where the main power lead is down at the bottom, these are at the top. The first screw for both of these is basically where the power for the device that you want to send power to goes into. So for this, the USB relay that we have that will provide power to the Raspberry Pi, this red cable would go in its first connection. When we hook up the camera, its red lead would go into this port. So basically just pop that into that port or to that socket, tighten that down, and then that would be the part 1 of connecting the power to this device. Now the second screw, we don't use the third screw at all. The second screw, we wire that directly into our power block. So we will take a wire, run it all the way over, and connect it into either A5 or A6, depending on where we hook this negative up at. So basically, the second port, you need to provide a constant power source to this block. So whenever this relay switches on or off, it takes the power from that block and basically transfers it over to this little slot here. So it's got power coming out of it, provides power. Now, you'll notice we're not hooking up a negative anywhere on here, because the negative just goes straight back to the power block for the negative on the power block. So you'll recall our system, our schema, we're using A is the positive and B is the negative. So we just take this ground cable, the ground wire for this power block, plug it into the B6, and that's all we have to do on that. So we'll go ahead and get this wired up, and we'll be back to it in just a second. Okay, so that's wired up now. So this is our power block that will power the USB-C on the Raspberry Pi. You see this first lead coming off of it is going into the very first outlet, and the second lead, also a positive cable, is going over to our power block. Of course, the ground coming off of this is also going straight to the power block, because obviously it needs a ground and a positive. So this is connected to the block full time. This is going through the power relay. So when that switch kicks on, it takes power from this wire and then transfers it over to that. So this is how you could actually reboot this device remotely using the app. Now, I will point out one more thing. If you're manually activating things, you can hit these 2 buttons right here. So this little button here corresponds to that switch, and this one corresponds to this one. Now, what we want to do real quick, let's just do a sanity check just to make sure that we've got things wired up correctly. And we want to just kind of check for power. When we hook up our power to our Jackery unit that's down on the floor, these lights will light up as soon as I hit the switch. So I'm gonna go ahead and power this up, press that in, and I'm gonna reach down below and hit the power on switch for the Jackery for this. Okay, so you see the little lights flashing on here. That's telling us we got power on that. And this light will blink continuously because it's in a programming mode. Once it's actually programmed and it connects to Wi-Fi, then that light stops flashing. Same thing with the unit on this side, we got the flashing on that. And if you look right down into the bottom down here, you can see our thermostat. It's on right now, and it's upside down, but it says 29.4 degrees Celsius. That's the current room temperature based on what this thermometer up here is reading. Now, that will be programmed. We're using these little buttons right here, but we'll work on that in a little bit. So we're in good shape. Yeah, these lights will continue flashing until it actually gets a Wi-Fi connection and set up and configured. So that's good. And then if we look inside of our Raspberry Pi, actually it's not on. So we'll go ahead and boot up the Pi. So let's hit this button right here. You might hear a little click. Okay, so that, you see the little light came on. That's telling us that we have power going to this device. Now if we look on here, turn off the light for just a second. Okay, see the NVMe light flashing on here. So that's telling us we have power running to that. And of course on the other end right there, that's our Pi LED telling us that we've got a system that's booted. All in all, everything looks good. A little red light kind of shining through the translucent material. But yeah, things working so far. So we'll go ahead and turn the lighting back on and work on wiring our next wireless power switch. Okay, now we've got the dual Wi-Fi controller wired up here. So you can see on this one, remember first block we hooked up our Raspberry Pi power supply here. Now this one is our camera power. So this wire is just a barrel connector. It'll run right up through the top here because this is where the camera power port is. And it's the little skinny wires running to the very first port here, and then the main power wire runs back around over to their main power block. So that's pretty much the setup on that. Now the last component to hook up, and it will go right here on this A3B3 to get its power, is our PWM controller. So you'll recall this is the device that actually controls how much power we send to our dew ring, because we don't want to have it wide open because we don't need that much power going to the dew ring. The enclosure itself, all the components inside of it will generate its own heat. Just with the Pi running, any of the electronics running will generate heat. So some heat will already be there traveling up to the dome, but this will just add supplemental heat with our dew ring. And if you look at the back of these type of applications have many different purposes. So if we look at the power on here, it says on this side closest to where the spinner is at, this is our DC in. So this is where our power into the device would be coming to. And then of course it has the positive and negative on there. If you can see that just on the right hand side, that's the positive, and on the left, that's the negative. And on the output, it shows motors, because you can use PWMs on motors to control speeds of them. It's just doing the same thing that we're doing with the dew ring. We're just limiting how much power we're sending to it. So we're going to go ahead and mount that inside. And I'm thinking probably we've got this little gap right here, and if you'll recall, this PWM controller only has a single hole right here by my thumb where it mounts to something. We're going to use a double-sided tape pad for this, plus that screw to keep it secured to the wall. But I'm thinking probably right here, mount it right there, because that will have there's a little void right here beside the Raspberry Pi power supply. We can screw through on this side through this and have it make sure it doesn't hit anything on this side. So I think that's where we're going to go with that, and I'll get it all wired up and we'll anchor it in. And pretty much the only thing we have left is really to mount the camera and power everything up and make sure that the Pi sees the ASI 533 camera and everything else powers up. So we'll go ahead and do that. Okay, so I've got the last of the power Wi-Fi modules installed here. This one is actually controlling the dew heater. And the reason I did not use a 4 connector, we could have used a 4 connector on this one for additional components. I've had issues with the dew heater being connected to one of these in addition to other devices that may be sensitive to power draws. I think the capacitor does not hold enough charge, so when it's actually firing up a component, one of the switches, that the dew heater, when it starts, it's generating heat, so that's obviously going to pull a little bit more power than, say, like the camera would on its startup. So whenever it first clicked on, it was actually causing the camera power to actually fade out, and that would cause the camera to just drop briefly, just long enough that the Raspberry Pi thought it was offline. And the only thing that corrected that was rebooting the Raspberry Pi. And of course, if everything else was already on, no other issues. But since these processes kicked on at different times of the day, like the dew heater, you don't need it on at 9 o'clock at night. Usually you're going to need it on at 2 o'clock in the morning when the temperatures start dropping, where it starts generating the dew in the dome, or on the top of the dome. The solution was to actually move the dew heater off to its own Wi-Fi power switch. Once I did that, I haven't had any other issues with the camera going unresponsive. So that was kind of maddening to troubleshoot. Eventually got resolved and we're good to go. Now I do have the camera installed. I went ahead and just put it in and got it all powered up and wired up. Of course, the power connection and the USB on this particular camera is directly on the bottom. And you can see I've got a dew ring up on top. And of course, that's my Mikey lens that connects to the camera itself. So this build is really pretty much done. The main things that you want to make sure that that none of the wires are getting into the moving parts. So I've got all these wires tied up here to stay away from the fan. Actually, there is one more component we need to do. We need to put our screens in so that we do not have bugs and stuff allowing access up into there. We'll do that screen next, and then we'll do the same thing on this inner part of the case. Okay, so the templates that you can download, these are on the same website that you would have downloaded the software from. It'll just say the Skyforge templates. So you can either cut this, if you have an X-Acto knife, you can just cut right around the edges of that and cut your template out like that. Or you just use a pair of scissors, and that's what I'm gonna do here. I've got some scissors that I will just cut around the edge. It does not have to be perfect. Obviously, you don't wanna go short on it because you don't wanna leave any gaps on it, but you can definitely go a little bit wider and let it tuck up on the sides if you need to. It's not too bad with a pair of scissors. The straight edge ones that we're going to do that go on the actual tube, that one would probably be easier with the X-Acto, since you can just lay it flat on your foam board, not cut into your materials or to your desktop. My second grade teacher will be proud of me right now. I'm staying mostly inside the lines. All right, so that's the, hope I showed that. That's going to be what we'll use on the bottom. And of course on tube is basically two of these. So what we'll do is we'll find our long part on here and basically just kind of cut that down right along that edge. Unfortunately, I didn't cut this screen straight last time, so I can't go straight across on that. Probably come up just a little bit, start here, and basically just cut this out twice. And that will be the width that we need to cover the holes on the other one. So you get the idea on that. I'm not going to record cutting this. I'll just show you what we're going to do once we get them all done. So we have our screen stencils cut out. So we have the circle for the bottom that goes here. And let's pretend that I did this at the very beginning, because in hindsight, showing a video of me putting glue on the bottom that could actually drip inside to the fan and any other components would be a terrible lesson. So go ahead and do this part first. If you're following this video and you're going to build your own system like this, do this part first. This way you don't have to worry about dripping glue in there. So I'm going to go ahead and pause the video. I'll apply the glue carefully. I'll probably just keep it tilted like this so that I don't allow it to get into the fan. And we'll do the same thing for this on the neck. It'll go on the inside neck of the tube itself, but yeah. Okay, so we've got the screen glued onto the bottom and didn't have too much drama with that. There's a couple spots are raising up, but mainly around the edges is the main thing that we cared about, making sure that was adhered very well so it doesn't ever blow off. And then of course on the tube itself, inside the neck, you can see we've got the screen there. So this basically air is going to draw through these holes, down the bottom, out the bottom of this tube stack here, or the cradle stack here. So we'll push that off to the side. I do have the device powered up, as you can see by the flashing LED. These are on the Wi-Fi power switches. So now we're to the point where we need to program these. So we need to tell these switches what device is on which port, and this way when you're setting up your schedules for things to either be turned off, or if you ever need to restart something, you'll have that ability to do that from your phone. So I'm gonna pause this video and I'm gonna jump onto the screen recorder. Okay, so our devices are flashing they're in a pairing mode. If they've never been configured before, the actual power switches that we were looking at just a minute ago, they'll go into a pairing mode, which it flashes 3 times and then pauses. 1, 2, 3, pause. 1, 2, 3, pause. That's how you know it's in pairing mode. So we are now ready to go ahead and add them to our eWeLink app, and this is it's spelled EWELINK, and this is the app that controls your power switches, how you can program them, turn things on and off remotely, schedule off and on sequences. So we will go to the plus key, we'll hit add device, and then by default it's going to try to connect it to your default network. If you do not want to connect it to your default network, I usually connect these on an IoT network just because I don't trust these Internet of Things devices. They're usually not very secure. Behind your firewall, everything's probably going to be fine, but you never know who wrote the firmware, things like that. So I usually put these things onto an IoT network so it's completely VLANed off. But so anyway, these are going on the IoT network. So I'm just going to hit next. Okay, and on the screen we have 2 devices listed here. We have one that has 2 dots, that's going to be our dual channel, and then one that has just a single slider, and that's a single channel. So let's go ahead and hit add, and we've told it that we want to put it onto the IoT network, so it already had that account and password. Okay, and it added it. You see a green check. We're going to hit next. Okay, and now we want to label this device so it doesn't just show up as device whatever on your screen. We're going to call this, since that was the dual, we'll call it the Washita Skycam Pi and camera. This way we know what this device is doing, because we're going to have another one that's going to be the dew heater. So we'll say okay to that, and we'll say done. Okay, so that one's good. Now we'll say done again. And now let's go ahead and add our other one on here. So we'll hit add device. Yeah, it's in programming mode. Sometimes if you wait too long, it may go into a standby mode. So we'll say next, searching for devices. And this actually, just as I did that, it went into the standby mode. So we are going to have to hold the button on it. Usually it's 6 to 8 seconds, and it will go into the programming mode. Okay, there it went. So it sees it now. So this is the single channel power switch. So we'll add that one, and it takes just a little bit before it will get it completely connected to your network. And one thing if you do have trouble getting these things paired, this happens sometimes. I've seen people report this. If you have on your cell phone, disable your cellular service. Just have Wi-Fi only. Only if it gives you problems. Just disable your cellular service. Sometimes it has trouble navigating which network it wants to be on. It may try to go out over the internet to try to talk to this device, which is obviously incorrect. But that does happen on occasion. So if that ever happens, just turn off your cellular service. Just have your Wi-Fi only on. Okay, so we'll hit next. Now we want to edit this one, and we will change the name. Click the X. So this device only controls the dew heater. So we'll say okay, that done. Okay, and next, done. Okay, so you have these devices pre-programmed on your phone. Now, I'm going to just click this, and you're going to hear this relay click on. This is turning the dew heater on, so I'm just put it right up next to it. Okay, you hear that click, and that basically the red light turns on whenever it actually activates the power, so you know that particular device has power. And if you have a 2-channel, you've actually got 2 red LEDs. If you go into the dual channel, click that, we have channel 1, channel 2. We just need to give these names, and you can do that by clicking up here. You'll go back into the name section. We'll click that, and this is where you have channel 1 and channel 2, and we can change those names. On this, now I know for a fact camera is on channel 1. Save that, and then on channel 2, we'll call that one the Raspberry Pi. So now whenever you're looking at the buttons, when we move back out to the main interface, you see camera and you see Raspberry Pi. And then there's another view that you can do on here where you can change the layout. Let's see. Yeah, you can go to list view. And this way you can see all your components directly inside the app without having to drill into it. So if you want to turn the heater off, you just click that. If you want to turn the camera on, it actually did turn the heater off. I don't know why it just didn't get a response from it, but it'll probably update itself in a second. All right, so that's it. Okay, now we are ready to discuss the programming of the thermostat. As thermostat, if you'll recall, we have it connected to our fan down here to where it will supply power to the fan once we hit our threshold on the thermostat itself. Now, if you're looking inside here, let's see, I don't know if this is going to come through with the LED flashing or not, but it's about 33.3 degrees, and we have our temperature threshold. I'll press this button, and it says 35 degrees. So 35 degrees is about 95 degrees Celsius. Now, it does not technically come on at 95 degrees. It has a 2-degree float before it actually turns on, and the float it's up. So it has to hit 37 degrees before the fan will actually turn on. And that just keeps it from cycling on and off constantly. If you set it at 95 degrees, once it went up, as soon as you hit 95 degrees again, it would shut off, and it would be a constant on-off process, which is not what you really want. So it waits until it hits 2 degrees above your threshold before it turns on, cools the system. Once it gets back down to your threshold, then it turns it off. So in order to change that, if I press this button
and we have currently at 35 degrees. These are plus and minus, so I can bring it up. I can say right now it's flashed at 35.0. Let me hit that button again. 35.0. If I hit that button, you see it's changing on the digit on the right. That's a 0.2, 0.3. So we're at 35.4 now, 35.6 or 35.5. You get the idea. Now we can bring those back down. I'll click that down. And back down to 35. So 95 degrees for me is a good threshold. That allows it to set the cooling temp that I want it to be at. Once it hits 37, which is around 98.6, the fan kicks on and it continues to run until we drop back down to that 95 degree set point that we had originally. So hopefully that makes sense. And the documentation on this device is not great. I fumbled through it trying to figure out what different settings were, but finally got around to understanding that's what it was. And the 2 degree threshold is the default on there, and that can be adjusted. You can go to a different programming mode where you can say, I want it to be a 5 degree swing. So my threshold's 95, don't turn on until it hits 100 degrees or the equivalent in Celsius on that. And of course, where you put your thermostat, the sensor matters too. Obviously you don't want to put it right next to the Pi, because if it's blowing its fan, it could put some hot air out too. Put it up into an area that's not going to be near where any other warm air could be circulating at, so you don't get a on-off switch, a false positive on there. So hopefully that all made sense. And if it didn't, just leave a comment and I'll try to explain it better. So one of the best benefits of these wireless power devices are the ability to turn things off and on remotely. But of course, the greatest curse of them is these super bright LEDs. These things are so bright. I think they probably draw a watt themselves just based on how bright they are. So I've got one on each side. We've got the single controller and the dual controller. And to make matters worse, when you power up one of these power devices, like I'm gonna turn on switch number 2, you get a nice bright red LED along with that. So what we're gonna do to fix that, and I'm gonna turn on the light, we're going to just take some electrical tape and cover up those LEDs. And I've done this on all of my enclosures. It works great. It solves the problem. And to make sure we apply it into these little slots, I'm gonna use a little plastic probe here. We'll make sure we cover. There's a second one right there. That's for the Pi. I don't want to turn that on and have to shut it down immediately. But yeah, we're just gonna put us a piece of electrical tape and tape it up against this wall, and then tape the remainder of it across this. And then we'll do the same thing. We'll just have a small piece that will cover that, and we'll do the same thing on the single controller that controls the PWM. And of course the PWM doesn't want to be left out, so when we turn it on, you'll see it puts a nice little bright LED right down there. So it wants to get into the party too. Big bright LED, but again, we'll just put a piece of tape over it. Problem solved. Okay, before we wrap up, I wanted to show you one more build. I'm doing this one for a friend that lives in West Texas. He's out by Big Bend, and from what I understand, they have some incredibly dark skies out there. I think he's Bortle 1. But anyway, he does not have a printer that can print ASA, and that's something I highly recommend for when you're doing one of these types of prints that are going to be outdoors. If you have to use PETG or one of the filaments that aren't really UV rated, you definitely want to throw a coat of paint on it just to protect it from the UV. Now, the cradle itself doesn't necessarily need to be the ASA, but any of the external things, the enclosure, the dome, any of the stuff that's going to catch direct sunlight, you definitely want to consider an ASA type filament that is UV rated. You can get by with PETG, but if you do use that, make sure you throw a coat of paint on it, because you don't want that stuff breaking down in the sun in a couple of years. But just a couple of details on this one. You'll see that he did opt for a PiCam HQ. You can see the little square board down there. It's the cradle. It has the drill holes to mount it on. When you choose that cradle, it automatically give you the pilot holes for that. The lens, I'm trying to think, it's like an Arsant or Arcant. I'll put a link to it in the parts list if you decide this is the build that you want to design after. But it's not a terribly expensive lens. It was pretty cheap, but From what I've seen, these things put out some really good images. I had one on a build that I had a while back, but not using that one anymore. He did opt to use a 3-inch dew heater ring instead of the 4-inch. Where he's at, it's very dry, and it's just not gonna, he's not gonna have much problems with dew out there, I don't think. And if he does, he can turn on the switch to enable that. But as you can see down here, there's the Raspberry Pi is mounted on the back plane back there. And there's the ribbon cable right there. Can't really get a good angle on it. But he's got the thermostat to control the fan. He's going to have that fan on continuously. I imagine it's pretty hot out there. He only needed a dual Wi-Fi power controller on this one. Remember on the other build, I had a dual and a single, one to control the dew heater. But since we don't have a very sensitive camera on this one that's sensitive to electronic disruption, we can run both the Pi and the dew heater off the same controller. And of course, this is the Raspberry Pi power supply, and there's the back of the Pi itself. And then here's the power distribution block, and then the PWM controller for that. But I'll go ahead and pause the video, and I'll put the enclosure on so you can see exactly how big this little dude is. Okay, so here is the enclosure completely assembled. And you'll notice one thing on here, his lens is barely peeking above the dew heater ring. But I checked it on the camera view just as a test, and it sees completely above it. I was really concerned that lens may pick up some of the edges, but it's above it, and this was exactly his spec that he wanted. And I asked him, do you want to raise the camera up? And no, leave it exactly as is. But he's not going to have a situation where he has street lights or anything coming in from the side causing reflections on the dome. He is in a truly dark site, so he said, just please print it exactly as I've given it to you, and I did, and it worked out perfectly. I will admit I was a little concerned about it at first, but it looks great. And I will take this out to my observatory so you can kind of see the size difference. On our design tool, I call this the tall model, but in reality, this one's shorter than the standard model. But that just gives you an idea of the flexibility of the tool. You can shorten the cradle, you can shorten the enclosure to any size that you want. You just got to keep in mind of what components you want to include inside here, because the components kind of just work inside this little ring here area. They mount on the back, on the side planes of the cradle. But if you don't have a lot of components and you don't need a very tall enclosure, by all means, print a shorter enclosure. You have that option. But we'll take this out to the observatory and get some pictures of it, compare my build versus his. I've got the big ASI 533, so mine naturally has to be in a bigger enclosure, taller enclosure. But that's it. All right, so we're out here at my observatory, and these are the two enclosures. This is the one on the right's my 533. This is the one that's been out here for quite a while. And this is the one I just printed for my friend. So you can kind of get an idea on the size. These things can be printed any size that you want. Larger as long as your printer supports it, but more smaller if you don't need all the space. But yeah, it's pretty decent size for a small enclosure for him. So I'll go ahead and get this mounted, and we'll let it run for about a week, and we'll ship it off to Texas. And hopefully he has a good experience with it. I think he's gonna love it. Okay, both enclosures are mounted out here at the observatory. The one on the left is the one going to Texas, to my friend's house out there. And the one on the right is the one that I built a while back with my ASI 533 camera. You can definitely see the size difference between them. And there's significant height difference on them. And that just gives you an idea of how flexible the software is. You can adjust it till your heart's content as far as the dimensions that you want to get on it, as far as the height. And your printer is your only limitation. How high can your printer actually print to? Mine caps at, I think, 255 or something like that, so I did the enclosure at 254 just to give a little breathing space. But yeah, it works great. And then out here in my observatory, it's all 12 volt. It runs off that solar panel system over there. So all of this gear being also 12 volt native, it works out very well for this type of setup. So hope y'all enjoyed the video, and check back often and see if there's any new content that I've got that you might be interested in. All right, thanks for watching.
And that's the full build. Your AllSky camera is assembled, sealed, and ready for the night sky. Congratulations, you built the whole thing. If you make one, I'd love to see it. Drop a photo or a question in the comments. Everything you need is linked below. The free design tool, the STL files, the full parts list, and if you jumped in part way, the complete series from design to final build is right here in this playlist. And if this helped you, please consider subscribing. I've got more AllSky and 3D printing projects as well as astrophotography projects on the way. Thanks for watching, clear skies, and I'll catch you on the next one.